Hello, check. Can you hear me?
Hi, Subramaniam.
Hey,
Thanks for
hi.
joining. Yeah.
Hey,
So we'll
sorry,
just
there
get
were
started in a couple of minutes.
Imran, there were two links given to me. I was on the other one, so I need to delete that, right?
Hi, Subramaniam. Yeah, please. I
Hey,
can see
hi.
the confusion here.
Hey,
Sorry for
sorry,
that.
there
We'll
were
get started in a couple of minutes.
And I checked that
So
there
we
were
will
two
just
links
get
given to
started
me.
in
I
a
was
couple
on
of
the other
minutes.
one, so I need to delete
Just
that, right?
be on standby. Yeah, please. I can see
Yeah.
the confusion here.
Hey,
Sorry for
sorry,
that.
there
We'll
were
get started in a couple of minutes.
And I checked that
So
there
we
were
will
two
just
links
get
given to
started
me.
in
I
a
was
couple
on
of
the other
minutes.
one, so I need to delete
Just
that, right?
be on standby. Yeah, please. I can see
Yeah.
the confusion here.
Hey,
Sorry for
sorry,
that.
there
We'll
were
get started in a couple of minutes.
And I checked that
So
there
we
were
will
two
just
links
get
given to
started
me.
in
I
a
was
couple
on
of
the other
minutes.
one, so I need to delete
Just
that, right?
be on standby. Yeah, please. I can see
Yeah.
the confusion here.
Hey,
Sorry for
sorry,
that.
there
We'll
were
get started in a couple of minutes.
And I checked
So
that there
we
were
will
two
just
links
get
given to
started
me.
in
I
a
was
couple
on
of
the other
minutes.
one, so I need to delete
Just
that, right?
be on standby. Yeah, please. I can see
Yeah.
the confusion here.
Hey,
Sorry for
sorry,
that.
there
We'll
were
get started in a couple of minutes.
And I checked
So
that there
we
were
will
two
just
links
get
given
started. Yes, yes. Audio and video are fully in sync. Please go ahead.
And my slides are visible, right?
Yes, yes.
Okay. Welcome all. Before we go in, can we have a quick dipstick metrics on the kind of audience we have, Imran? Can you quickly summarize what kind of audience do we have on now?
It's a mixed audience, to be honest, Subbu. Like these are people from different domains, and a lot of people do work in the manufacturing sector. But a lot of IT people are also here, and they are also interested in the IoT aspects of this industry 4.0, and essentially like. Look at some of the data part of it. I think there'll be a lot of interest. It's a combination of manufacturing and IT people in this group currently, and this is also being streamed on YouTube as we speak. So there are like some 15-20 people joined in there. So it's a mixed audience, Subbu. So yeah.
All right. Welcome all. Thank you. So I will try to keep this session very introductory in nature. If any of you have further questions, please feel free to reach out to me. I'll try to introduce you to the concept of 4 or the smart factory, the way it is referred to. And then, of course, take some examples and walk you through what it really means and how is it different from what companies have been doing in the past. Before I jump in, a quick introduction to my business. I run this company called Vegam Solutions Private Limited. We are headquartered in Singapore, and primary development center is in Bangalore, and we offer multiple solutions and
Excuse
technologies.
me. Excuse me. Kindly mute others' mic because it's getting disturbed.
Imran, if you have control, please disable all mics. Thank you. Yeah, so we offer multiple products and solutions that makes factory smarter. I won't go deep into my company, just to give you a history. We have been doing this for a very long time now. We started in 2007. Today, we touch more than 160 factories across the globe. We also offer our solution in more than 54 countries. And as you see, we offer multiple products and solutions around making manufacturing plants smarter. I would skip basic introductions beyond this. If any of you are interested, feel free to reach out here what we do. I would just jump into the context. These are the various products that we offer and solutions. So we have software and hardware, both industrial IoT, industrial smart factories, digital twins, sensors tracking. So with that, I jump to the core, right? What are the core challenges faced by manufacturing plants, right? If you look at it across the globe, okay, need not be India, it's across the globe. Primarily, they are always under pressure. There is always pressure to reduce cost, which is driving the industry, right? So you have serious need to reduce the cost. You also have a lot of times need to maximize production. This is very important because you cannot keep on adding capacity to build more and more, right? So you have to be able to do maximum out of what you have. So capacity utilization and doing max out of the capacity is something very important for a manufacturing plant, because the capital cost of setting up a manufacturing plant is extremely high. The other aspect which most manufacturers are very worried about is on-time delivery to customers, right? So how can I make sure that I'm able to really keep my commitments? I'm able to offer my commitments to my customer on time with the quality, right? So this is again a very interesting factor which they always strive to. These are all the deep challenges that you see in a manufacturing, right? how do I adapt to change, right? Like COVID happened, there's so much logistics change, right? There's demand change. Suddenly, you have less demand for shampoos and more demand for your sanitizers, right? So you need to be able to adapt to the demand and be able to produce and supply within time, right? So quick adapting to the changing needs is always been one of the biggest challenges of a manufacturing plant, right? Eliminate defects and losses. This is again pretty huge. Quality and losses are so very deeply embedded into these manufacturing plants where a lot of times they would actually have significant losses, but all covered up because they are never reported out. So you have defects, people take those defective parts and rework on it and make them sell. So net they actually sell those parts, but they are defective, which means they really have spent more time to fix them. So this is something again a big loss. And uptime is very critical, maintenance is very critical. So these are at a broad level the challenges that you see in a manufacturing plant. And apart from this, being sustainable is a big need of the day today. You want to have your manufacturing plants reduce the carbon footprint, which means you have to be more efficient, you have to be more productive. So it's in a good way beneficial to manufacturing plants to be sustainable because it adds to their overall competitiveness and overall revenue. So these are basically the drivers what are there out there. And to achieve those drivers, there's a lot of discussion around the smart factory, industry 4, IoT. There's a lot of buzz around it, right? So let's go a little deeper and see whether this is a hype or a reality, right? What exactly is this entire smart factory, right? What does it mean? Is it like automation? This is like a regular question I see. Will I have job losses in my plant, right? Am I talking about automation? Am I talking about robotics? Am I talking about adding more PLCs, DCS, IoT systems, right? What exactly is my smart factory? I'm sure a lot of you have heard this and understand this. A lot of you may also have questions around this, right? So let's little go deeper into it, right? It's not really automation. Industry 4 or smart factory is not about automation. It has nothing to do with automation per se. However, there is what you call there is a correlation between it. There is a connect between automation and smart factory. So people perceive that automation is smart factory. No. So I will give you examples of why it is actually not about automation, but it is about information, right? So let me give you an example. Today, you want to go out and you know that it's a sunny day, right? So you go with a normal shirt and normal pant, whatever you wear, right? However, there is a way of predicting that there is rain today. Now, if I know the prediction ahead of time, then I will actually go pick a raincoat and go out. Even though it may not look like raining, but I have a prediction based on data, based on science. So I would pick a raincoat and go out there. Now, the aspect of you picking a raincoat based on information is what we call as information driven decision, and any information driven decisions that you are making is actually called as industry 4. Industry 4 is all about data driven insights that are helping you make choices. Now if you actually go ahead and have a robo to put a shirt on you or put a raincoat on you, then that is automation. And if I can send this robo information in real time, then again it is industry. So automation is about manual jobs being taken to a robo or to a system. But industry 4 is about intelligence, it's about information, it's about insight that is driven on certain facts and data. So this is what industry 4 smart factory is all about. And I also get this question very often, right? My factory, my business is very old. We have very little automation. do we really have an option to go for Industry 4? We'll go into deep into this question actually as we move, right? So is it possible for us to enable something like Industry 4 in my factory, because we don't have any automation, we don't have any infrastructure, we don't have tools, we don't have anything, right? Is it going to give me return on investment? Is there a benefit for my organization by doing this, or is it just hype? Everybody is doing it, I'm doing it, right? So these are some really burning questions that I see from a lot of small and mid-sized companies across the globe, where what is this Industry 4? How much of it is reality and how much of it is hype? And will it benefit us? Is it going to be of any value to us? Can we really implement something in a factory like ours? So these are some of the questions I will try to answer in the slides today. I take a 1 second pause. Imran, is the speed okay? Is the voice okay? Do you want to have any questions in between, Imran? I think Imran is not there. Okay, so let's go ahead.
Yeah, the voice
sorry,
is
Subbu,
clear.
you were asking something?
Yeah, I was checking, is the speed okay? Is the
It's all
context
perfect,
okay?
Subbu. Yeah, please go ahead.
Yeah, perfect.
Okay. If anybody has questions, they can always reach out or put a message. Okay, I'll be happy to go deeper into any of these points. So I would take an example of a manufacturing plant, and then using this example, I would love to answer the questions we had in the previous slide, right? These are the questions: what is smart factory, and is it good for my business, right? So we'll take an example, go deep into this example, and start analyzing what exactly is this Industry 4 and how does it really matter, right? Let us take an example of a plant that is producing injection molded parts, right? It's a very simple factory where you have plastic granules coming in, and you have various molds, and based on the demand, you load a mold and produce parts, right? Now, a plant like this can have both Industry 4 and also automation, right? Now, what is this difference, right? So let's look at it. I actually go ahead and say I want to put a robo. The robo will go ahead and pick the parts once they are ejected, and then places it on a conveyor where the next stage of packing or cleaning happens, right? So this is like a very typical scenario where injection molding machine is producing a part, and once the part is produced, there's an ejection that happens, and when it is ejected, the robot catches that part and takes it, puts it into a conveyor. Now this entire process comes under automation. So I am actually replacing a human collecting that part and putting it onto a conveyor and doing some job on it, right? So this is primarily an automation, and there could be various areas where you may want to do automation based on your factory and based on your need, right? Your business need can define what kind of automation I want to do. But what is Industry 4, right? Now, Industry 4 is actually the aspect where I have a mold and I am producing parts on it. If you understand injection molding, you know that a mold can only produce X number of parts without having compromise on quality. So that X is based on the grade of the mold you produce and the parameters like pressure and raw material. So every mold, you say that there is a life for this mold. After that, you have to do a maintenance on that mold and do additional tests on that mold to reconfirm whether you can continue using that mold or you have to make a new mold. Now, this aspect of information ahead of time or while it is produced coming to the operator is what your Industry 4 is. This is what is called as a smart factory, where when I'm producing using a mold X and my software or my industry 4 implementation is counting how many has it produced from the time it was created, and is also having ability to know that this mold is designed for 1 lakh parts, and once it reaches say 90,000 parts or 95,000 parts, it will tell you, hey, it's reaching its end of life, 1 lakh will be very soon, so you need to take it for maintenance. Now that is industry 4, that is smart factory. So automation using robots is also looked at as smart factory, because your smart factory implementers can send this command to a robot in real time, and the robot can change the mold itself, right? So there could be that kind of an implementation where they both can coexist. However, your pure industry 4 is about all related to information and information driven insights coming to either a man, machine, material, operator in the time where they could use that information to make the right choice. Like in our first example, we said, because I knew that there could be a rain today, I took a raincoat. So I made a decision of taking a raincoat just before I stepped out of my house, right? So the information helped me make the right decision. And that aspect, when you adapt to a factory, it becomes a smart factory. We can extend it and say, okay, I'm using a pump to pump the plastic granules, and the pump is having certain vibrations which predict that it's bearing may fail in the next 24 hours, right? So do you want a pump to fail while my production is running, which means I may lose a lot of raw material consumed in the production process because I have a bad pump, so my quality suffers, right? So if I knew ahead of time, then I can stop my production, I can completely clean up my entire cycle, fix my pump, and then restart, right? So you're looking at, how do I avoid losses in the production? How do I make my decisions better, right? So this is what we call a smart factory, right? So it could extend to a lot of aspects. What about temperature? What about humidity? What about my machines being maintained at the right time, right? So there's a lot of places where you could bring in some form of technology to help you make choices which are based on facts, which are based on data, which are based on insight. And if you can do that to a plant, then you have actually achieved a smart factory, you have achieved the industry 4. So automation is about replacing humans, and industry 4 is about making right decisions, is about helping you make smarter choices in the manufacturing plant. So this is how we look at industry 4. This is how we look at smart factory. Any questions around this?
Okay, so Subramaniam, I had one question in this. So, what is the general consensus on specific IoT developments for various individual industry verticals? Right. So, are there any standards for development of such devices in the industry 4.0? For example, let's say you have you talked about measurement and monitoring systems, right? From an IT perspective, are there standard protocols here for, let's say, IoT device manufacturers who can essentially follow a standard and say this is how you report certain data? Or is it basically like up to the system integrators and the device implementers to figure this out?
Very interesting question. It's very relevant, right? Uh, there are standards. There are standards available. These are mostly to do with communications. These are mostly to do with how you communicate, connect, and share information. Like, for example, there is a standard called MQTT, right? MQTT defines how a sensor can transmit data, right? So it's a very broad definition. But how the information in MQTT is structured is not defined by standards, which means I may have vendor A giving me a vibration sensor and vendor B also giving me a vibration sensor, and both of them can support MQTT as a standard interface. So far it is good, right? But when you actually get the data in MQTT, I may have vendor A have a format which is very different, and vendor B may have a format which is very different. So today there is no standard available that defines how the information is structured. There's no standard. However, there are a lot of standards available which define the physical or data level connectivity and communication. Which means if I'm using MQTT, then I have standard MQTT servers available, standard MQTT receivers available, broadcasting is available. So there are a whole set of tools available for you under those standards. But there are no standards available to actually standardize the core information itself. Right? Every time you will have to relook at that. So this is something which is an opportunity and also a problem, right? Opportunity because developers now can make money by integrating different kinds of sensors for you, right? Because every time you bring something new, I need to integrate it, I need to understand it. So there's a money to be made. On the same note, it is also opportunity for the developers to bring additional value to you by not having to be constrained by the standard, right? So I can add a lot more information to the same thing and make it better. So it's a really complex information that goes there. So there are no standards for the
for this next question that you are about to answer for us. We have no systems in place where to start. So I think that's the single biggest question on everyone's mind right now.
Correct. Yeah, that's really what I see as a challenge. A lot of small and mid-sized companies face because one is they don't have access to the global market, so they don't know what is the state of technology or state of availability in the globe. And they don't know where they stand. And because they're all small and mid-sized companies, they're always under the pressure and feeling that, hey, my plant is not fully state of the art, right? Because I'm very small guy, I don't have capital, right? So this is something which is a very critical problem, and Industry 4 has a beautiful solution for that. Let me go to that, okay? Let me jump to that slide, right? Yeah, so I will go back to my previous slide later, but let me answer this question, right? When we look at Industry 4, right, let me take an example, okay, and then answer it based
sorry,
on...
but I don't think the slide moved. So there's something here. We're still seeing the same smart factory slide. Yeah, now we can see the use cases. Yeah.
Okay. Is it moving now?
Yes, we can see the use cases slide. Yeah, please go ahead.
Oh, it's taking time. I think it's not moving. Okay, I understand the problem. Let me fix it. Yeah, I know. Okay. So I'll answer your question and then go to use case. Okay. So I'll answer this question, which is very important, right? How do we approach Industry 4? Because we are not too sure, right? What is the best way? The approach, the way I recommend this approach is based on your need, based on your affordability, based on your use case. You can approach Industry 4 in a very low cost mode without having to do a whole gamut of big bang approach, right? So you don't need to do that. Let me give you an example. Let me go back to use case, right? So let's say we want to solve the use case of, say, what is the effective utilization of our machines in the plant, right? So I have 20 injection molding machines. I'm taking example of injection molding because I want to keep the continuity, but I can adapt this to any industry that you have, right? So I have 20 injection molding machines, and I, as a plant owner or a operator or a manager, I don't know how effectively am I utilizing my machines. Are my machines operating 8 hours a day? Are they producing the rated number of components? Are there any times when they are going down? If they are going down, why are they going down? If I know, then I can fix it. Are my operators utilizing these machines properly and producing, or are they basically killing time? So it's a very basic pertinent question, right? What is the effective utilization of our machines? And you go to any plant, this is a question that would be of interest to a manufacturing plant, right? Now, how can I get industry 4 to get me this information? Very simple, very basic question, right? So I want to get this information, and how do I do it? My plant is not automated. I don't have infrastructure. I don't have software. I don't have this, right? Now, the way we approach this problem, the way I recommend people to approach this problem is there are very low cost, very low cost devices available in the market with a lot of processing capabilities and a lot of what do you call community-driven information out there. So, for example, I'm showing you a Raspberry Pi, right? Raspberry Pi is available for 3,000 rupees in the market. Not a very fancy cost, and has a lot of capabilities into it. So whenever you are small and you don't have infrastructure and your appetite for expenditure or risk is less, you actually go with the ultra low cost approach of doing something called as a POC, proof of concept, where you bring in these kind of devices, you bring in very low cost resources to help you set this up. There are a lot of engineering colleges. There are a lot of freelancers available out there who can quickly create a concept out of this, which is a working concept. However, it is not necessarily a professional solution from a large company, right? So you say, this is my use case. I want to know effective utilization of our machines. Then you say, how do I do that? I want to know how many minutes was it on, how many minutes was it off, and I want to know if I produced 20,000 parts for 20,000 hits, or I produced only 10,000 parts at the end of the day. Very simple information I want to calculate, right? You can actually get a 3,000 rupee, 5,000 rupee based IoT device, plug it to one of your machine. You can get a sensor that can help you convert that information, and you can actually do using a bunch of young kids and students, freelancers, a POC around that. So you don't need a big bang investment for it. Once you do a concept and once you go through that journey, you would know what is the benefit out of this. Is it really going to benefit me? Do I have ability to recover all my investments by doing this? Can I make better decisions out of this? So you evaluate that by building a working concept using low cost available tools and technology there. And this is what Industry 4 brings to you, where you can actually do things which earlier were not possible. Before all these IoT concepts came in, you cannot do something like this with very low cost using an engineering student to build this, right? So this is possible. So you can actually do it. What you need to look for is you need to look for quick wins. What use case for me gives me the maximum benefit, right? Is it utilization? Is it quality? Is it delivery to customers? Where am I? Is it maintenance? Is it downtime? Is it consumption of my raw materials? Is it productivity, right? You as a plant owner or you as a plant manager have to find the use case that is most relevant to you. And this can be different for different people. So don't need to follow what others are doing. It doesn't make sense to you, right? It is your problem, your scenario. So you pick that use case. And then you go to a low cost approach and do a POC. Now here is the challenge I see a lot of times. I do a POC for say 20,000 rupees and I see a value, like ROI, I'm getting my return on investment and it's very valuable to me. A lot of times people try to take that POC and roll it out as a solution in the plant. I have 20 machines, I want to roll it out for all the 20 machines. Now that's a very risky proposition. When you are doing a POC, the idea is to validate that by doing a industry 4 enablement in a very low cost. I want to validate if I have large return on investment, right? Now, once you have validated it, please go back and find a stable, robust solution out there in the market, or talk to a larger company that can give you a professional solution for the same problem that you have done ultra low cost, but at a much higher price. Now, why is it important is a POC is not generally scalable. A POC, what you built is for a small case and a small scenario, and it's not really going to cover a lot of requirements you would have as you grow, right? Your desires increase as you start making money, and that's how your requirements also increase. One stage you have one requirement, then you increase, then you increase, then you increase, right? So a POC approach is not going to help you for rollouts. You need to go find a right solution for it. Now that you know what is the benefit you get, you calculate and say, "Itna paisa main laga sakta hu kya? And will I get my benefits out of that?" Right? So the industry 4 is a game changer because it is allowing a small plant to adapt technology, evaluate technology without having to do a lot of capital investments and risks, compete with a big company by way of being small and bringing that technology ability. And once you are certainly sure of the value and return, then it allows you to create something robust which is lasting and scalable. So it's a very powerful capability that comes to your disposable to change the equations what exists today. You don't need big investment. So it is possible for you to look at industry 4 enablements for the use cases that you are interested in. And once you know that this is the use case I want, then you will be able to really come up with a blueprint of how to achieve this, and enough solutions out there to achieve whatever is the blueprint you have. So this is how I see industry 4 changing. This is why industry 4 is so very powerful and game changer in the space. Did I answer your question?
Yes, Subbu. Yeah, that I think the template for this you have set, where you're talking about doing small POCs with Raspberry Pi devices, and then when you're going in for a full-fledged layout, there you go for more robust industry solutions, right? So I think it makes a lot of sense to me. Yeah.
Yeah, it's all about the ROI and the value that you want to derive out of it, right? So if it's a large company, then they already know, they will directly jump on. But if you're a small player, you still have a lot of options, and there is so much of information available today that you will be able to quickly put a small team, maybe talk to an engineering college, pick some professor, pick some students to set it up, and you are ready to go. You're ready to go, evaluate, validate, and doesn't take too much of complexity. But when you scale, of course, this approach won't work. This approach won't work because the moment you are scaling, you need something lot more thought through, lot more robust, a lot more scalable, and that's where you go back and evaluate whether this investment will give me the returns what I want. So that's a very quick concept that I want to bring in, that industry 4 is not about automation. You don't need an automated plant. You don't need to cut your manpower. You don't need to cut your jobs. Industry 4 is about reducing your losses. Your losses could be productivity losses, quality losses. Your losses could be in the way of not keeping your customer happy. Your losses could be in the way your machines are not maintained properly. Your losses could be you're investing in the wrong kind of places where you have already 10 machines. You go and buy 2 more machines where your 10 machines are not utilized, but you have a bottleneck somewhere else, right? You have a bottleneck in your inventory, you have a bottleneck in probably your electricity, you have a bottleneck in your storage, right? There could be bottlenecks in n number of places, but you're investing into something. So Industry 4 is all about identifying what are the root causes where you're losing and how these root causes are hurting you. So it's about bringing that information out. And to do that, there are so many technologies available which can be quickly adapted, tried, and evaluated, right? Once you are through with that, once you are certain with that, then you can actually do an investment and go build a solution. So this is what I wanted to introduce. This is basically what I thought would be valuable to a broad category of people and not really go into a specific scenario. So happy to discuss any specific points further. Happy to touch upon anything specific you are looking at.
Yeah, at this point, we'll open up to the audience. So if there are any questions, specific questions to Subbu, please, you can go ahead and ask. In the meanwhile, I do have some questions of my own till somebody else can chip in. So it's a very cliched question, Subbu. So how much is Industry 4.0 hardware and how much is software and how much is processors? Like if you can give us a percentage breakdown from your own experience, I think it'll help set some expectations like for people who are trying to take this up. That is one thing that we would like to understand.
So the aspect of Industry 4 is about information, not about hardware, infrastructure, processing, right? So if you are able to get that information and if you are able to consume that information and generate that insight, then your Industry 4 is achieved. So based on the scenario and the use case you are solving, the cost involved can be into different buckets, right? So if I'm doing a simple use case where I'm only looking at how effectively my machines are running, how much on, how much off, what is my quality. If I'm looking at a very simple use case, then probably you can keep your hardware sensors and stuff to let's say about 20%, your infrastructure to another 20-30%, and probably the rest 40% goes to the implementation, which is primarily get somebody to do that, use a cloud server where you host it and run it and do the POC. So it's very contextual, it's very specific to the use cases that are of interest to you. It's not something very generic, but it's a combination, so you cannot run away from them. So you need all the components what you asked, and there is going to be a variable cost on all of them.
Sure. Just for any questions that anyone might if you have any quick questions for Subbu, just quickly unmute yourself and go ahead and ask. We have a couple of minutes if anyone has questions.
So I have my email ID and phone number here. You guys can always write to me, reach out to me. More than happy to be of some support. So we
Sure.
we do
Subbu,
have
one request I had. Sorry for interrupting. So one request we had was if you can also share us some already existing use cases of some industry verticals, specifically from India, where they have driven a good ROI from a Industry 4.0 implementation, I can circulate this within the audience, and that could be like a lot of insights for them.
Oh, sure. I would share some case studies for you. It's also there on our website where we have described, and there are like, for example, maintenance is a big use case which is very low cost, available, where a lot of companies are benefiting. When we look at maintenance, has the maintenance done? Is the maintenance really effective? Am I reducing my downtimes by way of bringing this technology, right? So there are a lot of implementations where people are benefiting, people are really seeing value, and these are very low cost implementations that are available for small and mid-sized companies. A lot of Indian companies actually have already enabled them and are seeing value. Productivity monitoring, again, a very powerful tool. We've seen some nice use cases. Companies like Recall and stuff had clearly seen benefit out of it. So it's a very simple monitoring tools that will tell you how much am I using my machines, how much am I really consuming, right? What is happening? So
Good morning, Subbu.
morning, Abdul.
Okay, I just joined very late. I think there's an echo. Can you hear? Can you hear me?
I can hear you.
Yeah, we can hear you.
Yeah, I have joined very late. I just saw in the later part about your presentation on Industry 4.0 and a smart factory. You have mentioned about the machine utilization, the losses that can be. Have you done about the human losses? We are in more of a labor-oriented sector. Is there any way to measure the loss coming from the workers' underperformance, staff and executive underperformance? Is there a way to calculate apart from the machines?
Yes, so when you look at performance, right, you also have ability to look at the productivity, right? So productivity can be tied to both machines and individuals, right? So you don't need to monitor a human like a machine where I don't need to put a sensor on them, but I can do both my in and out tracking, where if I have a production line, if I have a workflow available, then I know at what workstation, what came in and what went out. So if I'm able to track that, I know the productivity of that particular workstation. So there are a lot of scenarios where people want that to be monitored, not from a pure tracking of the performance of the individual, but also to understand the overall bottlenecks involved and how that is impacting the customer delivery. Like, for example, I'm doing a shirt. If one station is down, where maybe I'm putting buttons, right? I'm putting buttons in that station and that station is down or slow, then my entire deliverables are stuck. So monitoring in and out to a workstation is something which is very regular and common, and there are a lot of simple tools and technology available to do that. However, it is a very industry specific, so we'll have to go a little deeper to understand what are the human elements involved and how they are involved to really come up with something feasible.
Okay, thank you.
So Imran, are we good on the time? Did we take?
I think we are good on the time. So thanks, Subbu. So obviously, I think a lot of people will reach out to you over email and phone. I'll wait for the case studies to circulate within the group. And thank you very much. I know you're traveling heavily this
I
week.
also have one quick question. I think if I can ask the last one.
Please go
So,
ahead.
Subbu, how do we implement? See, this is a leather industry belt, right? So you may be knowing. So, have you seen any use cases which can apply to the leather industry or the shoe footwear industry? Have you been involved in any of that?
Yeah, so we've looked at some of those cases where quality is a factor. How do you apply adhesives? How do you effectively monitor them? How do you control the quality of your process, right? So there have been scenarios where we have been involved in that. May not be small companies, but mostly large ones in that sector. If you have some very specific areas of pain points that you want to address, and if you can share those pain points, then I can either give you references or give you some pointers of where to look for. It's all about, as I said, Rafiq, the pain point for you is very different to the pain point for somebody else. They are never same. So you need to be able to say, hey, these are my pain points that if I address is going to give me a financial edge to my business and gives me value to cater my customers, right? So once you identify that, then it would be very easy for somebody to look at that and see if there is a technology way of addressing that by bringing some information driven implementation.
Okay. So as you know, this is very resource intensive industry, right? So from a lot of manual labor and the quality of workmanship is the key part. So I'm just trying to understand how that can be utilized because there's a lot of that the intricate work activity that is done by the employees rather than the machines in case of the shoe industry, right? So I'm just trying to understand what are the tools and what are the sensors that can be applied there.
Yeah, so it is very similar to your textile industry. Okay. So there is also very similar in terms of human intensive. It's not much machine driven. It's mostly to do with how the operators are working, how they are working in harmony, how quality they are producing, right? So these are all very similar industries, and we have seen very good successes in that industry using industry for enablements. But these are larger industries, so I don't know very specifically the size of the sector you're referring to or the size of factories you're referring to. But if you look at large garment factories in Bangalore, right, the big boys who are all exporting the Gokaldas and stuff, right? They all have enabled various tracking, tracing, and monitoring capabilities for their cloth to shirt or a pant manufacturing. And they've been able to identify losses and work on it. So there are scenarios, there are use cases of these available out there in the public. Vegam as a company has not much worked with this industry, and also Vegam as such has not worked with smaller companies. So I may not have a lot of uh, uh, insights from specific cases, but I can definitely help you out with identifying the right approach.
Yeah, just to quickly add, Subbu, to that question from, I think, Wahab Bhai here. So there was one
Definitely,
question
definitely.
about specifically like how do you measure some losses in terms of productivity and so on. So I could see that in Industrial 4.0, I am like, I just got aware of this topic this week after speaking to Subbu. So in no way I am an authority on this, but I did study the vegan website like very, very clearly, and I have seen people and asset tracking solutions where it's being utilized for a different set of metrics where we are talking about in terms of like green zoning for let's say safe and unsafe activities and so on. But those could be implemented for also tracking the placement of people and so on. So that could be one thing we could look at, Subbu. Yeah, I just noticed it on your website, so that's it.
Yeah.
Yeah, so I think having some use case, I will talk to Subbu and get some use cases from him so that we can help out the mid and small players apart from the big ones, right?
Yeah, thanks a lot, Subbu. It's I think 6:30 for you in your time zone. Thanks a lot for joining in very, very early. and we will of course like be in touch with you, and as a community we'll be in touch with you and ask for more questions. Thanks a lot for joining in, and all regards from all of us. Yeah, thank you.
Thank you. Thanks a lot. All the best. Bye-bye.
Yeah, thank you. So yeah, so with this we'll step on to the next session. So that session is from Shoaib Fahad. So I think a lot of people might know him as well, specifically with the photo that we circulated of him. So he's someone who studied in Abdul Hakim College, and he's been a techie right from his college days, and he's a director and CTO at Pogyan Technologies. I'm not sure if I got the spell wrong. Pogyan? Sure. So, and he essentially is leading the technology execution for various technology platforms, and he's also essentially has built a team from scratch in a way. So that is very inspiring, and he works on the holy grail in computing these days, right? Which is basically Kubernetes and serverless platforms. So without much ado, I'd like to give it over to Shiv Fahad. Shiv, please take it over, and thanks for accepting our invite and joining us.
Hi everyone. Sorry, we both are sitting in the same room, so okay, guys. I'll present my screen.
Assalamu alaikum.
Hope everyone is able to see my screen. Okay. Thanks, Imran. Thanks for the short introduction of what I work with my company. And today I'm going to present on Kubernetes intro and the digital enterprise. So what you could look forward in this presentation is what does the modern enterprise look like, and how do we achieve that? Okay, so a very quick introduction about my company and about what we the journey so far, and how we are working on our own products as well. So we are Projan. We got incorporated in 2011, but I joined in 2013 there as a CTO. So my journey is like for 8 years, and we built a team from scratch, of course, and we very fortunate to work with quite a bit of premium customers, I would say. Our top customer is Microsoft. We work with Microsoft India on the enterprise services, basically. So there is a product called Dynamics 365, which focuses on the enterprise side of the Microsoft story. So we did work with them. We also work with SAP and Ericsson. So just a short overview there, just highlighting some projects, what we did with them. With SAP, we worked on automation of bill of lading. So they did a bill of lading workflow automation with blockchain-enabled technology, and we helped them build the digital ID trace of the documents going completely through online, and without any exchange of documents and all that. So it was a very niche zone with that. With Ericsson India, again, we work with them on their telecom CRM. So we have worked with them for the last 3-4 years now. Then we have a couple of German customers. So our primary focus, as I said, is enterprise software. So these companies also, we work with them on their products. So basically doing product consulting with them. Kobil is a digital ID provider from close to 30 years now. So we work with them on enhancing the platform. We had to work with Germans on sub-second latency deliveries and stuff like that with them. Then we also work with CBM IT, who focus on the safety of the employees. So we help them build a complete SaaS product from scratch, and it was also nominated in the German market for the top 3 innovations for a couple of years back, basically. So they are a self-funded company from that perspective. So what happened in this journey is we eventually did a lot of work on the enterprise, which was like repeating and reusable. So we thought, why not get on the products side of the story and build this for the modern enterprise. So how would you look at the enterprise if you are setting up today or for the next 25 years or the generation to work with? So we built we are building a product. It's still not released yet. It's in alpha version as of now. So but we have some pilots using it, and we help them build their products. So you can think that we are like a middleware company. So we provide the tooling and the middleware, you call it a middleware, and then they build products on top of it, or their ERPs or whatever on top of it. So there's a very short overview of what we do in the company, and hopefully the journey continues quite a bit. Okay, so today's agenda on what Imran had told me is a very IT specific topic. So I'm going to have a balance between IT and non-IT here, because I know that it's too dry if I just speak about Kubernetes here. So what I want to do is I want to explain how a modern enterprise will look like and what you could expect in the next 25 years. That becomes the gold standard for defining your architectures and your products and all that. Okay, so first I'm going to cover on the digital enterprise. Then I'm going to talk about Kubernetes and building cloud native solutions, what it means basically. So and how are you getting equipped to go to that level? And then comes some technical topics with a very level understanding of the architecture and some concepts to just understand. And there is a recorded video I already made, so I don't mess up during the demo. So I'll just run at the end of this slide, basically. Okay. So what is a digital enterprise? So what is the innovations that are happening in the market, and where are you heading in the future? So you might have heard about all these terms in different aspects. So I'm going to give an example of it on each of these topics. So what it means by it, and how can you be future ready to go to that to reach your goals. So basically, you want to run your companies for at least next generation, and you want to have startups or SMEs popping up everywhere in India now, with all the focus being self-reliant and all that. So what we can expect, and how does the technology side of the solutions help you reach that goal? Of course, business is still business, but how does technology help in today's age? And that's what we are going to look at in this slide. So first thing is digital transformation. So this topic you would have heard quite a lot. So I'm going to give an example so you understand what it really means. And just to give a definition of it, it's building modern business applications that can streamline operations. You have rapidly integrate your existing ERP systems and build on top of it. So basically, digital transformation is moving out of your paper-based processes and your human-oriented processes to more automation, more process-oriented aspects of your company, and how fast, how agile you can be to reach this. Because in today's world, just a very short example, the DHLs and FedEx of the world, so basically from the logistics domain, they were in a pretty much flux state, basically, when Amazon came and took over the whole retail market to online, and they were like delivering in a week's time initially, and then now it has come down to days time or 2 days time. So what do you think is happening in the background? So all these systems are connected, basically. So there is an API economy that has built with these enterprises. So DHLs and FedExes just expose their APIs. They're still doing the same business. They expose the APIs, and there is an integration happening between these providers. So these providers between the sellers, the merchants, Amazon, who is hosting the marketplace, and then the delivery side of the story, and then you have first mile delivery, last mile delivery, all that coming into play for your order to reach to your home. So it's not just one person sitting somewhere and trying to package it and send it to you via a courier email. So all these integrations happening in the background with very tightly coupled interfaces, which have to work 24/7. There is no room for error. So that's what it means. So you could make your you invest on this time so your business can grow exponentially. So being for a consumer focused markets. Okay, and then there is the other side of the story where you build for B2B and this for B2C basically. And the second thing is app modernization. So people over the years or businesses over the years have invested quite a bit on their existing infrastructure. So they don't want to migrate. So if you look at a lot of these supermarkets that you could go in Chennai or Bangalore, you would see them just still using this black and white IBM system. So they don't want to modernize those systems. They don't want to bring in new technology that will completely change their way of approach, because you have to train people, you have to bring in new things, and always change is hard in the enterprise. I mean, you can talk about any industry, change is always hard. Even IT, change is hard. Of course, changes in IT happen very, very fast, but still it's hard. Okay, so you upgrade your legacy systems without disrupting or risking your investment, but then you build on top of it, kind of a integration layer, and you modernize it. So I'm going to give one simple example here. We worked with a customer last year and who is in France, and they are building regulatory compliance for banks basically. So they told us that they have a software which used to run in the 90s, okay? And they want to take that and run it on the modern system because they want to expose that as APIs and banks can consume it. And I mean, we don't know the technicality of it because we just know what was the problem. So what we did was we took it and we ran, related to Kubernetes itself, we ran the old systems from 90s in latest environment, and we packaged it in a way that it's consumable, it's dynamically invocable, and then you start the machines and it starts processing whatever he wants. So that's kind of a modernization we're talking about. Like, even if it's done in the 90s, we were able to modernize it, and it was just a concept initially, but then we were able to deliver it in some time. The third aspect for this digital enterprise is an ecosystem that you have to build, which is like a platform. So everyone is not just making silos of information. See, if you look at an organization or an enterprise, you have multiple departments or multiple organizations under a big hierarchy that would work. But each of them will be focused on their sales and on their cost centers, and there's no information sharing between them. I mean, we had a customer discussion last year where they had their products put up in Amazon, but the sales and the manufacturing was not connected. So they launched a product, and within a week they got 2 or 3 stars because the things was not working, and the sales was not able to connect to manufacturing and tell this is an issue, please rectify it. So they were like, all this happens because you have silos of people working and focusing on their aspect. They forget the larger picture. So when you build the new enterprise, or when you think about it, you have to think from a platform ecosystem perspective. So you build an ecosystem around it, and people are able to integrate. So one other example is if you see a lot of these government services or citizen-based services are becoming automated. And in India also, it might soon happen. But there is a lot of these ecosystem citizen-based services are getting launched in Europe and US, and just with your ID, everything is online. You don't have to go and stand in queues to get your passport renewal or your driver license renewal. So to build a system like that, they have built a platform ecosystem again. So different departments of these services, they come and talk together and extend the same solutions, build that point. So I wanted to focus on this slide a bit more, so you get the picture what I'm trying to talk in the rest of the slides. Okay, so what it means to become a digital enterprise. So it's not just the big organizations. I'm also talking about startups that are getting popped up everywhere in the country now. Like you have even people starting from villages now. So what it means in becoming this digital enterprise. A company can integrate and expose its business capabilities as API. So as I told, it's an API economy. It's growing really, really fast. We also work with Gartner to understand what are the market trends that are happening and how what are the focus for the next 5 years that we have to do. And this is one key aspect. Every company is exposing their capabilities as APIs. So if you're consumer focused, then this is a thing that you have to do. And if you're B2B, then there's other type of integrations that you have to do. Being agile, being flexible and scalable are really, really key to becoming successful. You can have a 10-member company, but your turnover could be really big. You don't need to have always the manpower multiplied by so many hours and you pay for that to reach a level. You don't need that today. Today, you have each industry or each vertical of the industry focusing on smaller aspects, and you could start off like for one example recently I read about is a B2B company. They have storage units across India because they want to reduce the time for the last mile delivery that happens. So for example, we are in this remote village now, so I mean, not remote, sorry. We are in Vellore, so if I place an order, so I should be able to get in 1 day's time or half a day's time. So that's really customer experience you're talking about. So there is a company doing this, and there's not more than 100 people, but they have pan-India presence, and they got huge funding to do that. So that's what it means. And now coming to the technology aspect of it, what it means is you build cloud native technologies, which I will talk about, and it helps you scale. So you don't need to start like if you think about technology investment, you don't need to start off saying that I need 50 lakhs or 1 crore for my technology side of the story, and then only then I can go. No, it's not like that. You could start with as low as 50,000 or 20,000. Just give a number. Not really that specific thing, but you could really start small, and then as you keep growing, as you get customers, as you get investment, you go to you scale up. A quick slide on what it means. So on the top, you basically see the different experiences that people would use. For consumer based, it's customer experience, CX basically. Then you have cloud infrastructure. Then you have integration to external services. You have your legacy applications, and then you have your microservices talking to each other and coordinating in a way so your business can move forward. Then for B2B side or business side, there is employee experience. So for consumer focused industries, it is CX, and for employees, it is employee experience. So you really utilize that time. So like I come in, I log in, I go to my dashboard, I see what I have to do because I've already scheduled my Monday, and I know what I have to do for this whole week. I don't have to think too much. I just go and do my work, 8 to 5, and I get off. So that kind of experiences you have to bring. It really optimizes how you work and how you organize your work. Okay. Now we start talking about IT now. So any just a 2 minutes pause here. Any questions in the points I had explained here, and then we talk completely IT now.
I think, Shiv, we can go ahead with the next steps, and then
Okay, sure.
Let's come back at the end for questions.
Okay, so just a brief history, because I want you guys to know these terms which I will be using in the coming slides. So just a very short history of where the cloud was and what it is now. Okay, so we when the cloud started, again from Amazon's and Microsoft and Google, it was basically virtual machines, and there's something called hypervisor, which is like a OS kind of a thing, but more bare metal, runs on the machines, and there is So you have an operating system on top of it running, and then you have an application and binaries running on top of it. So there was always this handshake happening between the underlying infrastructure and the operating system here. So so let's say I want to provision a machine. A request comes in. I want to provision a machine. Then it takes like 2-3 minutes to spawn, and then your application starts, and then the thing works. So you need to identify your compute, identify your request, and then provision the systems from when your software is running. So you cannot really go on demand at that time. So what happened was that there was a technology shift like 8 to 10 years before, and all these Linux operating systems had brought in like a lighter virtual machine inside the existing operating system, which was very, very close to the operating system itself. So just to be a little technical there. So this container engine is like, when you run the application, it doesn't take extra time to provision and create. So you could technically create whatever we did in 2 hours, it was brought down to 20 seconds or 10 seconds or even 2 seconds if you have the setup done in that way. So you could technically process your request. When it comes, you reply back within 3 seconds, which is the industry standard in general. When we talk about performance, if your application responds back in 3 seconds, then it's good enough. Okay. Then what is cloud native? Cloud native is a term used to explain technologies that help to create, deploy, and operate applications in a scalable environment in public, private, and hybrid clouds. So, okay, so this is a little technical again. So, but then you can understand that there is a scalable environment that is set up, which scales up on demand and then comes down to 0 as soon as the request goes down. So let's say, for example, maybe on a given salary day or the 1st of the month or 2nd of the month, you need to process 1 million in an hour time. Okay, so those kind of scenarios. So you scale up and then you come down immediately. And why Kubernetes? So how do you achieve this? This is one of the ways to do it. There are other ways to do it as well, but Kubernetes is now becoming a gold standard for managing or orchestrating these kind of setup. Like how Java in the 80s and the 90s was a technological shift in developing enterprise applications. Kubernetes is now bringing that for the cloud infrastructure. So you are no longer a developer who just needs to know a language and then you start developing it. You need to know a little bit intricacies of how your system is going to run. And Kubernetes helps these for developers especially to define things in a much configurable way. So which we'll talk in the next slides. So you could use Kubernetes to build cloud native applications, elastically scale up and down on the fly. So as I was giving examples, so when the request comes in, process it, respond back, and then go down immediately. You don't need somebody to go and click and delete those machines. Second point is cluster management. So it gives a very easy way to manage your cluster of nodes. Now before this, it was very hard. You have to go and set up manually and do all the infrastructure setup, networking and all that. So, but with this, it's very, very simple. Then with microservices, so which is the rage these days, but then microservices actually started 10 years back. But now people are more into it and making it like a unit of development. So identifying a service in this cluster of nodes. So I have a very high intensive processing thing which has to run in a big machine, and all the other requests has to go to some other one. So the service discovery when the request is hitting has to go there. So all those routing and distribution happens on demand with Kubernetes. Then there is also replication. So you could run multiple services, not just one, because one would serve, let's say, 100 requests. You can just run it 100 times. Replication is on the fly, and you're able to process that request. Okay, and with the architecture, so a very short overview again here, explaining what Kubernetes actually has in the underlying stuff. So if you look at this diagram, so on the left-hand side, you have a control plane, which is like the manager or the orchestrator, and it is run in a typical production setup. You have to run multiple for high available nodes, but you get this for free in most of the cloud providers. So there is a way to access and deploy from these control plane nodes. Then you have the worker nodes, which actually runs your code, runs your services, which is running on your virtual machines or physical machines, basically. And then you have to define this setup in a declarative manner. So you would say my services need, let's say, 2 compute CPUs and some RAM to allocate, and then you want to run it. So you define it in a file, and then you submit that to Kubernetes, and Kubernetes will take care of deploying it. So it has become really, really easy. Cloud is becoming abstracted now, so anybody can be a cloud developer. You don't have to know too much of what is happening underlying, but then it's all getting automated from that. From a concept wise, this is purely basic of the basic what I'm just telling in this slide. So there is something called pod, which actually runs your code or your service. It has its own IP address and your process ID. It has its own network and a host name. Okay, which means when it runs in its own shell, you can say like that. So there is no other guy trying to access it. It just runs, allocates, and runs on one of those nodes. So to create a pod, you need a deployment file. So in the deployment file, you have declared what you want and what is your service and what is the path to access that service. Then it gets deployed. Then there is something called services, which is an abstract way to expose your application running on your pod throughout the network. So now you have like hundreds of these pods running. How does it communicate with each other and things like that? Okay. Quickly switching to a very short demo. So I've already recorded this. It's a single node installation of Kubernetes with micro Kubernetes, which is a product from Ubuntu. And I have recorded this session. So I'm going to deploy an app there, and you can access that app application from the external service space. Okay, so as it goes through, I'll explain what it's doing. So here I have a machine already with installed with 1.19 version of Kubernetes, and I have a README as well. So I'm just pasting the points from the top. So there are some initial setup that you have to do, which sets up your environment. These steps basically do that. And by the way, this code I have put up in GitHub, and you guys can access it if you want to try it out. So it's setting up the network now, and then I just add a shortcut, because I mean I'm a lazy guy, so I don't want to type the whole thing always. So I keep it very small, like K to say it is Kubernetes. So here we have to configure the kube folder, which tells the
There's a request to share the GitHub repository.
Yes, it's there in the ending. So when I go do kget no, it lists out. Sorry. Okay, when I do this kget no, it means it's getting the nodes that is currently running, because it's a single node installation. It just gives me the current node that is there. So when you run it in a cluster, you get multiple of these nodes. So what I've done is I'm looking at the pods. So I do a kget po. I mean, it's a shortcut again, but you have to type pods. Then you see the current pods that is running in, because I didn't deploy anything. There is nothing as of now. So what I'm doing now is I'm just looking at the other pods that is running in. So because it's a network setup, which I ran, and these services enable the networks for the deployments to connect, basically. So this is something running at the Kubernetes level. Okay. So what I do is I'm also doing a checkout of the GitHub project. Okay. So I've done the checkout. Now I'm running the deployment. So if you remember the previous slide, so there is a deployment file and there is a service file. So when we run the deployment, the pod starts basically. So here I can look at the information about the pod. So there is a service or a Docker image that I created. It's a very simple Node.js application. So when you hit the request, it just tells the host name of the environment. So if you again remember in the previous slide, I said when a pod is created, it gets its own network, it gets its own host name and its own network stack. So that's what we are seeing here. When this code runs and when I try to hit it, it's going to tell me the host name of the system. You could also look at the logs of the pod, and whatever log you do, you could see there. Okay, this is the typical service setup. So we again call kapply to create the service. Once you do this, then you can access it from the network. I ignored this error because when I was recording, I forgot to remove a particular thing. So like with pods, we can also do kgit services to look at the services. So now I'm trying to hit the service with the IP address and the port number that we exposed there. So as soon as I hit that, it said hi from a Node app deployment, which is the host name. If you remember, if you do a kgit PO, then you get that name. So that's the host name. So that's it from the demo. And for all of you who are interested to know what else is there in Kubernetes, there are like a lot of topics that you can study about, and there's something called service mesh, which enables you to run all this cluster of microservices in a big environment. Then there is file storage, replica sets to run database services. Then scaling up and down. Then you have Knative, which is the serverless computing on Kubernetes, which we discussed, saying that like when the request comes and starts. Then if you want to go more deeper, then there is something called Kubernetes Operator. So there are several startups in the IT world who are just enabling features on Kubernetes because it's still new. Features like backup and restore and very simple stuff. They're building companies on that and getting sold for like crazy amount of money because they are really into it, like going native on Kubernetes as well. Some links for you guys to go through and understand what we went through here, pure technical again. So you could also be part of CNCF, which is the Cloud Native Foundation, for which hosts Kubernetes as a this open source thing. There are a lot of things inside Cloud Native articles that you could read about. There are also a lot of courses that you can be. You can be a Kubernetes expert doing all that. Then slides and code is available in my GitHub. I'll share this PDF to Imran so we can circulate around. And thanks for having me. I would really thank Imran for giving me an opportunity here. And to contact me, I have a LinkedIn profile, and you could always email me as well. Any questions on anything that you want to work with, you can always reach out. Thanks a lot. And we can just keep 2-3 minutes for questions.
Yeah. So there's a question, how is Kubernetes relevant to Docker? I think the
Yes. Okay.
similarities
So
between containers and Dockers. I think that was lost.
yes. Yes. Okay. So Docker is basically a company. So they popularized containers. So Kubernetes used Docker initially, but now they have moved to a more open Docker specification. So it's not following the Docker company itself. They are a startup who popularized it, but then now it has moved to more standard-based things. Yeah.
Yeah, but still, Docker container is what people are like very familiar with. So I think the relevance there is like, look, containers were kind of created by Docker and popularized, and Kubernetes just took it forward to make it. So initially, Docker also did something what Kubernetes wanted to do in terms of Swarm and so on, right? So Kubernetes has just taken it much deeper into the cloud.
Yeah.
And that's the relevance between let's say Docker container and Kubernetes in that sense.
Yeah, true that. Kubernetes got adopted much bigger than Docker.
Yeah. Any other questions or comments or feedback or like you wanted some quick questions? I know this was a very intro kind of talk. Shiv does a lot of work on Istio and so on, so we might do a deep dive with him some other day. But if there are any quick questions, so literally you could just set it up in your own laptops and be started with this. So forget about all the hype around cloud and so on. So just set up micro K8s on your own local laptop. If you're just starting to or wanting to get started, I think that would be the best place. I think all modern laptops are capable of running like very simple workloads of Kubernetes and Docker. So get started with that and then play around. So there are a lot of open source code contributions available where you can, let's say, set up WordPress on Kubernetes and play around with that. I think that should be the way for someone who is just getting started into Kubernetes to get started with that and take it from there.
So there's a question from Rahman. Can we host multiple containers in pod? If yes, how the single IP of pod can manage multiple containers? So to answer that, yes, you could run multiple containers in pods, but then both the containers should have different port numbers. Okay? It's like you can think it's like a operating system, and when you set up, you can't run two processes with the same port number. So it'll be with a single IP, but then you're running in two different ports.
Yeah. So just to quickly add to that, so there are two types of components for networking in Kubernetes, right? One is you can do a node port where one of these containers will take the IP of the host itself or the pod itself, right?
Yes.
And you can also then do the SVC service mesh, right? So if you are in a public cloud, right? So typically you can use a service mesh and essentially get an IP assigned to all of these pods. So let's say you're running 100 containers, so you get 100 private IPs and then assign it to 100 containers and access them. So earlier days, people used to use node ports when it was not standardized on the cloud that much. So that used to be a big pain point. But in all the big clouds, this has been solved, right? It's nobody uses node port on production. So for that matter, so everyone uses service mesh. So a quick answer to Abdul would be just use service mesh and your problem is taken care of in that sense. Sorry, Shiv,
no issues. I think we have the networking guru here, so I'm more from the application side, so I don't really go into that much details.
I actually think in the last question, what will be the amount if you want? Are you talking about going into the cloud? It's not very clear. So yeah, any further questions, or we will of course, like Shiv mentioned, share the slides, and also the links are much more easier over the slides. So please go ahead, download the YAML files he has shared, set up I think it will be like a wonderful feedback for Shiv if all of you set up Kubernetes on your laptop, especially the techies here. And then you can probably also get in touch with him for any questions or feedback that you have. I think the icing on the cake would be somebody does a chip commit to your project and says, look, I have done one improvement on this. So yeah.
Okay, I think it's time up now. So,
Thanks a lot, Shiv. I think it took just 30 minutes, but the entire demo was done and a very good intro onto Kubernetes, which I'm sure will be appreciated by a lot of people. And thanks to all the participants. I know that the virtual summit does not have the same kind of a feel as a physical one, but still being part of this at a very short notice in a way. Thanks to all the participants. Thanks to all the volunteers, especially Irshad, Inam, Suhail. So they put in a lot of effort to get this infrastructure up and running. And the recording of this will also be available on YouTube. So if somebody had any tech problems or connectivity problems, or they were not able to attend this for some reason, please do take a look at the YouTube videos, which will be shared later. It's already live, so a lot of people joined there as well. And one request is, like, please keep the feedback coming in. What worked for you in this session? What could have been better from the organization's perspective? We'll be happy to take those feedback and plan for the next sessions that we can. Thanks a lot, Shiv. Thanks for spending your valuable time on a Sunday with us. It's always a pleasure to host you. And yeah, thanks everyone. Thanks a lot.
Thanks, guys. Bye-bye.